All right, everyone, we're going to go through our practice exam and our first problem, which is going to be a statics problem. So we have a 20 kilogram ladder, 10 meters long, as we can kind of see here, in length, surfaces with the coefficient of friction of this, but the hash marks the other surface is frictionless, so we're going to ignore any forces and any friction in this scenario. What is the maximum amount of force can be applied before the ladder moves? Also, the weight acts as at the same location where the force is applied, basically at this half length here, the G, or basically at the center mass, or centroid. Also, exactly. All right, so idealizations, we have to consider friction. We need to consider the mass of the ladder, so that's what we're going to do here. Coordinate system. Now, I'm going to take this body, and I'm going to free it from the surroundings, my FBD, and we are going to say that there is going to be some reaction force. I'm going to say this is going to be some F1. There's also going to be some frictional force. So when I pull the ladder here, it's going to want to go down. So it wants to oppose the direction of motion. So I'm going to say mu S F1. Here, there's going to be a reaction force pointing up here. So force reaction 2. There's going to be some force here, F. And there's going to be some weight, where weight is equal to mass G. And that is it. So let's go ahead and let's start to solve this problem. So what do we have here? So we know weight. We don't know what is this force here. We don't know what this force here is. We don't know what this force here is either. So we're going to have to write out, we do know this. 3 equations for 3 unknowns. So let's do sum of the forces in the x direction. And that is going to be equal to, must be equal to 0. Isn't static so nice now? Plus F, and that is it. Sum of the forces in the y must be equal to 0, which is going to be mu S F1 minus W plus F2, and some of the moments. So now we need to kind of select the moment. So again, we want to pick the location where we can cancel out the most forces effectively. So we either want to put it right here or right here. So I'm going to say the moment about 1. Moment about 1 must be equal to 0. So again, let's go ahead and look at what's the perpendicular distance from our origin. It's going to be this distance here. So what is this distance? Well, it's a triangle. And it's a triangle with this angle of 36.87 degrees. And we want this distance right here. So what is that going to be? So it's going to be, this hypotenuse is 5. So it's going to be the cosine of that, right? So it's going to be 5 cosine of 36.87. So that will be that distance here, the cosine, not the adjacent one, because we're looking at the perpendicular distance from the line of action of the force. So that'll be the cosine. So that takes care of this force. What about the distance here? Well, that distance will actually be the perpendicular distance from the line of action. Well, it'll be the sine. And actually, we need to multiply this by, we need to multiply this times the force, because that's going to be the distance from here. The distance from here will be the same as the distance here, which is just going to give you, again, perpendicular distance from the line of action from our origin. So we can look at that. So that's going to be minus, because again, I'm going to have to flip to curl in direction, I'm going to have to flip my fingers. So minus W times sine of 36.87 times 5. Because again, hypotenuse. All right, so we've taken care of those two. And then finally, the last direction is just going to be this perpendicular distance from the line of action, which will be what? Now my hypotenuse, my triangle, same angle, but now my hypotenuse is 10. It's still going to be in the positive direction, because if I basically flip my fingers, it's going to be there. So then it's going to be plus 10 F2 times, and I want this distance here. Oops. It's perpendicular distance from the line of action. So that's going to be sine of 36.87 degrees. 3 equations, 3 unknowns. We know what to do now. So let's go ahead and let's solve it out. So I'm going to delete everything. I'm going to quit the kernel, and then I'm going to quit the kernel, clear everything, then let's see what happens. So I'm going to say that my mass is equal to 20, my g is equal to 9.8, my weight is equal to m times g, my, what else, mu s is equal to 0.4. We also have our problem that, let's see, let's go ahead, fx equals 0, set that equal to f1 plus f. Our fy, set that equal to 0, is equal to, actually, fy equals 0, set that equal to f1 minus w plus f2. And I don't want to produce those. And then m1 equals 0, set that equal to 5 times, and that's 5 times f, right? Yes. 5 times f times cosine of 36.87 degrees. Make sure you have that in your calculator. Cosine times f minus w times 5 times sine of 36.87 degrees. And then plus 10 times f2 times sine of 36.87 degrees. And let's type all of that in. Let's solve fx, fy, m1. Oops, let's go ahead and see what we've got here. Let's see. Weight, F1, so let's go ahead. Actually, where are we? Degrees. See, when it's in blue, it's not a variable. So there, and then there. So if we look at our solution, our F2 is fine, F1 is good. All we have to do is really flip the sign of our force, which we had previously, and then we'll be good to go. So let's go ahead and do that, and we'll see you all in the next video. Thanks.